So yeah, if this takes any longer than 10 minutes, I will be very disappointed in myself. I will prove once and for all that I'm just I talk too much. So today is the 15th of September, and today we're going to be solving what I'm going to call simple radical equations. This fits in our first unit as I was looking through the curriculum and the things that we're supposed to accomplish before we take our first district assessment. This fits in. So I thought, let's get this knocked out. There will be much more difficult radical equations that will embed themselves later on. I think it's after unit 2. But these, I say, there's absolutely very little meat on this bone here today. So simple radical. First off, the term radical, don't let that vex you. Radical is a term that very generally refers to any type of root. So like a square root is a type of radical. A cube root is also a type of radical. So that when you hear that word radical, like if we were surfers, it would mean like, hey man, that's radical. In math, it's a root. And so radicals can be square roots or cube roots or fourth roots. We will deal very specifically with simple square root equations. So we keep that generalized sort of moniker on there. We call them radical equations, but these are all going to be just square roots. And so just be aware that when you see the word radical, that's what it refers to. So the idea here is that we have to be able, as you know about solving equations, like you see a -4, you do a +4. You see a ×3, you do a divide 3. You see a divide by -4, you multiply by -4. Everything, I'll say this a lot, everything in math can be killed. Everything can be undone. Everything has what we call an inverse operation that can make it go poof. And so what we're going to try to inverse away today are square root signs. So our first example will look like this. That might look tricky to you, but just I'm telling you, a minute and a half from now, you're going to think, "Wow, I got this." And the examples will not get any more difficult than this. So sometimes I scaffold my lesson, like let's start easy and work our way up. This starts easy and stays easy, for the record. So the battle cry for us, which again, most of you got it, you heard it with the last couple weeks, has been get the absolute value by itself. If you got that memo, you're doing well. Get the absolute value by itself. Our battle cry with these is get the radical by itself. And so the thing we're about to do here in about 30 seconds can't happen until we do that. There will come a point when we're not allowed to, and that's when these get really, really hard. But for today, can I get that radical by itself? Yeah. Who has to go away? The 13, the -13. And we have simple operations in math to make him go away. So we're going to add 13 to both sides. And I, of course, would not expect that you would, show +13 on both sides, but I'm going to. And so I'm left with the square root of 2x + 7 is equal to -12 + 13, which is 1. And it's at this point that the magic happens. And like I told you earlier, everything in math can be destroyed. That's the essence of being a good equation solver. Like when we see logarithms, we'll use exponents. When we see exponents, we'll use logarithms. We see division, we use multiplication. Everything. What do you think kills a square root? Because that's what I want to do. Is because the 2x and the 7 are not free to move about the cabin. You'll start hearing me say that more. They're stuck, right? They're in like prison. How can I free them and get them out in the open? Yes. Thank you for saying that. If you think about it, a square root can be killed off by a square. If I square a square root, I feel like I'm right back where I started. And that's really what solving equations is all about. Make something go away, we're good to go. So I'm going to take this left side of the equation, and I'm going to apply some parentheses, and I'm going to apply an exponent of 2. Because that square will perfectly kill the square root. And of course, fair is fair. If you square the left side, you have to square the right side. Okay. So on the left, when we square the square root, there's really not too much excitement here. What do you think we get? Yeah, it just, the root sign basically just melts away. When you square it off, it just goes bye-bye, gone. The contents don't change, it just drops down. And then on the right side, what's 1 squared? We get 1. And then from here, it instantly goes from an algebra 2 problem to like a 7th grade math problem. You just subtract 7, get -6, divide by 2, and you get -3. So our answer is going to be x equals -3. So the ending is usually pretty simple, is what we find. This process right here, I want to tell you, I'm going to have you put a little comment into your notes. This process, there are certain things in math that when you do them, they cause bad things to potentially happen. And one of those instances is when we square both sides of an equation. When you apply exponents to an equation, there are these types of answers. You've seen them pop up before. They're called extraneous solutions. So I'm going to put a little comment here, something just in nice casual English, like this can create bad answers. And so what that means for us is that it's not our fault, right? It's kind of like when you were doing this last quiz, how sometimes you would get answers on you remember how on the equations, you'd sometimes check them and they wouldn't work? It's not because we did anything wrong. It's just because that answer wasn't meant to work. It's called extraneous. And so we always, now that we're in the land of roots here for a little while, we want to check our answers. And I don't think you'll encounter many extraneous ones today, but we want to form that habit now. And it doesn't take long. It's super easy. So like if I think my answer is -3, just work with me here. I'll use a little green arrow. Right here, what's 2 times -3? And what's -6 plus 7? And what is the square root of 1? And what is 1 minus 13? It's definitely not 12. It's -12. And then and I look at that and I say, nice. So that means that my left side is -12. My right side up there is clearly -12. That means I can now put a box around this and say, you're good. You work. All right, let's try another one. This one's going to go a lot quicker because now that first sort of introductory one is done. This will be fast. So we have the square root of 8x plus 4 plus 10 is equal to 16. What do we do first? It's minus 10, and we're going to get the square root of 8x plus 4 equals 6. And what do we have to do now? Square both sides. Good. So we're going to square the left side. We're going to square the right side. No need for parentheses on the right side because it's just a singleton. What do we get on the left? And what do we get on the right? Yep. And then we subtract 4 and get 32. Divide by 8. You get x equals 4. And then we just take a quick, it should take you 5 seconds, if that. With me talking, it takes longer, but with you in your head, it goes quick. Put 4 back up in place of x and just vet it. Check it. 8 times 4 is 32. 32 plus 4 is 36. Square root it, you get 6. 6 plus 10 is 16. Piece of cake. Okay. Let's do this one. Nothing to it, right? So I assume you got the basics down as far as like, what do? We start by subtracting 1 from both sides, and we get the square root isolated. So we have the square root of 4x plus 25 is going to be equal to -6, but minus 1. It's going to make him -7. And now what do? Square both sides, right? That's how we're always going to free away that root sign. I always picture it like a crane, like this math crane comes and just arm reaches down and grabs the root and throws it in a junk pile. So when I square the left side, and I do use parentheses this time on the right because I'm squaring a negative number. So when I square the left side, I get 4x plus 25. And on the right side, what's -7 when you square it? Definitely positive 49. So it's just business as usual, right? And then I'm going to subtract 25 from both sides. And I'm going to get 4x equals the answer to that. And then I'm going to divide by 4, and I'm going to get x equals 6. And if I'm a lazy person, I'll just put a box around it. But if I'm someone who listens to my teacher and says like, oh, I remember he said I should check these, then I'm going to do my due diligence. I'm going to put it back up in and see what happens. So I'm going to take my candidate 6 and I'm going to plug it right back where the green arrow is pointing. What's 4 times 6? What's 24 plus 25? What's the square root of 49? What's 7 plus 1? What's 7 plus 1? Yeah, I don't mean to talk down and ask you stupid questions, but that's the process. I go and I do all the math. And then what this now says, what this problem now says to me is that 8 is equal to -6, which is, of course, a load of malarkey, right? So in a case like this is now an extraneous solution. I would say, well, you don't work. I tested you and you don't work. Therefore, this particular equation has no solution. I say I don't think you're going to see a lot of that right now. I just want you to be aware that it's out there. So always check your answers. You guys, bless you. Do you guys have any questions about this? I don't imagine that you're going to struggle with this at all. The assignment, I think Otto posted about 10 minutes ago. So it's there. It's on Delta. And I don't remember how many I put in there, but how long should one of these take you? 30 seconds? Yeah, so nothing to it. You guys will get this done in class.